I'm starting back on slide 83. So let's talk about the long beak and the short beak one. Remember, the long beak bird has the advantage in this environment because his beak can reach into a tree to get the insects, where this bird has a disadvantage from his mutation to where it makes it harder for him to reach into a tree to get the insects. This animal has two choices. One choice is to die off. The second choice is to move to a different environment. So now this bird is going to move to a different environment. Let's say this bird ends up in California. In California, he may find that he doesn't need to reach into a tree to get the insects. He may be able to pick the insects off of a limb. Now, over time, what will happen to these birds is that all of the long-beaked birds will reproduce, and the majority of their birds will have long beaks. All the short-beaked birds will reproduce, and the majority of the birds will have short beaks. What's going to happen over time is that this is going to become its own species. And this group of birds will become its own species. And because they become their own species, they will no longer be able to reproduce with each other. So now we have created two different species. So simply because this species of bird separated, when you separate and you reproduce with other short-beaked birds, you change the gene pool. Now the genes in this population will only consist of short-beaked birds, and the genes in this population will only consist of long-beaked birds. When these birds can no longer reproduce together, you have created two new species. This is called speciation, making new species. That is one way or one reason that evolution has occurred. Let's talk about coevolution. Coevolution is the evolution of one species influence the evolution of the other species. We know that co means together, so they are going to change over time together. Let's say, for example, your best friend starts to get smarter and smarter and smarter. You're going to evolve with your best friend. You're going to get smarter and smarter and smarter with them, hopefully. If not, let's say, for example, you have a best friend who starts to act phony. They're acting phony, so you're going to start acting phony. You guys are evolving together. What happens in this example is that the moth and the flower, they're going to evolve together. Over time, this flower evolves to live the longest. Because this flower is evolving to live the longest, only the moths whose tongue can fit the flower will evolve too, and the rest will die out. So because this flower evolved, because this flower changed over time, the moth had to change, or the moth population changed over time. So when we say that the moth evolved, I'm not saying that year after year his tongue grew. I'm saying year after year, the moths with the longest tongue survived and reproduced, and the other moths died over time. Same thing with this garter snake. This garter snake is going to eat newts, which are similar to rodents. And the rodents have a chemical that's going to poison the snake. Some snakes have this mutation, so they got this mistake in their DNA to make them resistant to the newts. So over time, as the newts change, the snakes become resistant to the newts. So the newts over time develop a chemical to poison the snake because of their DNA. So you have a group of newts and they have a mutation. That mutation helped them become more poisonous to snakes. So the poisonous newts will be able to reproduce. Now you also have some snakes who has a mutation and make them resistant to the newts. So those snakes that are resistant can eat the newts and they are going to be able to reproduce. My favorite is mimicry, and we know that mimic means to copy. We're on page 163 now. Mimicry is when the organisms have evolved to share common characteristics. I'm not saying that the organism changed day by day to look like something else. I'm saying that the group of organisms that can survive is the one who can blend in. For example, let's look at this moth or butterfly. So this moth right here had a mutation. It makes one of its wings actually end up looking like an owl's eye. So because this mutation is helping this moth to survive, this moth is living longer, able to reproduce, and is mimicking another animal. Same thing with this animal right here. Mostly they are green, but this lizard happens to have a mutation with his skin color that ends up helping him mimic a tree branch. Because he's similar to his tree branch, he's able to blend in, reproduce, and make more organisms that looks just like him. We have a walking stick, this animal right here. I want you to attempt to find him on these tree branches. If you cannot find him, that means that his adaptation has helped him to survive in his environment. The praying mantis right here normally are green, but this one seems to have a mutation that also changed their skin color. Because that mutation is helping him blend in, he's able to reproduce, and a lot more praying mantis will be able to have this brown mutation. Same thing with this chameleon, who has a mutation and is playing dead in these leaves. This would be the chameleon right here, and you should be able to spot him, or hopefully not be able to spot him in this situation. This mutation has helped him to be able to live, reproduce, and make more offspring that look similar to him. So these are all things that have helped organisms to survive. The environment has played a role in evolution. We know that the environment decides which adaptations or which mutations are favorable and which are not. It's not up to the organism to decide if it will be more fit, it's the environment. My favorite is antibiotic and pesticide resistance. They're basically going to be the same thing. Pesticides are chemicals used to kill insects. Now, if that insect gets a mutation and the mutation make that chemical not work, then the insect is now resistant to that chemical. That insect can survive, reproduce, and pass on their adaptation to offspring. For example, if we have roaches at this school, and I spray the roaches with the Raid pesticide. It's a bug spray. Now, let's say it kills most of the roaches except 3. Those 3 have a mutation. That mutation is going to be able to pass on to their offspring. Now, when they reproduce, all of their offspring will have that mutation. I can spray Raid on them if I want to, but it's